Now that we've thought about the data representation, let's make some examples for the new interp. This is the old interp, which took just an expression in an environment to produce a value, where interp of numc5 with an empty environment would give us back numv5. Now we need to provide a store, so we provide empty store when we're starting off a new program. And instead of getting just a value back, we get a result back, so we should expect a v cross s as numv5 and the empty store, because interpreting a 5 doesn't change the store at all. So that's our simplest possible example now. Let's look at an example with a new form, a box C form. This program is supposed to mean create a new box with the value 5 inside of it. So if we start out with the empty environment and the empty store, then we will get a result back. We have to get some value back and some store back. The job of box is to allocate a new cell in the store and also return a box value. So the value part that we get back is a box v, whereas the store part we get will have numv inside of it somewhere. And specifically, it'll have some cell that maps a location to numv. And we're going to arrange our allocator of boxes so that it allocates cells starting from 1, 1, 2, 3, and so on. So since this is the first and in fact only thing we allocate in this program, that box will be at cell 1. It contains a numv5 because that will be the result of interpreting the numc5. So that cell is going to be in the store, and that is the one that this box refers to. So this is how a box refers to a place in memory. It has a location in it, and that location is mapped in the store. That means our representation for values has numbers and closures as before, and a box v, instead of relying on racket boxes, will rely on this explicit notion of our own allocated locations. And then we look inside of a box, we take this location, find it in the store. So in particular, the store is, in this case, just has a mapping for 1 on top of the empty store. So that's the complete example for using a box C. Let's look at our next form, like setBox. And here you can see I've switched to using a parse form, but it's all the same. So my program allocates a box and then changes the value inside that box. All right. So as we saw before, well, what we expect to get back is a 6 because that's how I've defined setBox for the book language. It's going to return the value that we put into the box in addition to setting the box. As we saw before, this box 5, when we interpret that part, is going to end up changing the store. It's going to allocate cell 1, map it to 5 in the store. So the remaining question is, what else does setBox do to the store to change the 1 to a 5? And the answer is that it's going to override store cell 1 to 6 instead of 5. So these overrides will pile up in much the same way that extra variables can pile up in the environment, but that's okay. We will always start from the beginning to look for the current value of a cell. And so if we looked for the value of this box inside the store, we would find that it's 6 before we find that it's 5. This program doesn't actually use unbox, but if an unbox is used, this is where it would look.